Okie dokie. So this is problem number 26 off of the Box and Whisker Central Tennessee homework. And the question is, box represents the guests of a local restaurant throughout the year. How many guests are represented on the Box and Whisker plot? Well, how many are they? How many guests are represented? That would be what? 100 minus who? 15? And that would be what? 85? So that's 85 there. You agree? Okay, so now what you have to understand about a box and whisker plot is the whisker is 25%. This whisker amount is 25%, and each portion of the box or the box itself represents, guess what, 50% of the data. So it says what percent of days had less than 55 guests. So 55 guests here, less than 55 get, it would be 75%, right? 50 plus 25. Did it take it? Yeah. Yeah. So that's how you do a box of wheatgrass, your things, and everything. All right. Got nothing? How about probabilities? Why? Did you watch the video? Did you watch the? Ooh wee. Okay. Well, let's go fix the problem. Which one, honey? Oh, okay. All right. So you're gonna kick yourself once you figure out this one, okay? Because it's really not as hard as what you think it is. All right. So if you randomly select a letter from the phrase "Sean wants to eat at Olive Garden," what is the probability that you select a vowel? Okay. Now I need total letters, and then I need how many vowels, right? So let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I got 27 letters. Do you agree? Okay, now what is a vowel? A vowel, A, E, I, O, U, right? So I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I see 12 vowels. See if you see the same thing. Well, not 12 or 26. I said I got 27 letters. Consonant. That's any letter that's not a vowel. So if I got 12 vowels out of 27 letters, guess how many that are consonants? 15 out of 27, right? Yeah. I know. I told you, you'd kick yourself after you see this. It's all just kind of, okay, what is the question really asking, right? So this would just be consonants. Consonants. I don't know how you spell that. Consonants. Spell it, baby. Okay, say that again. Yeah. Uh-huh. Okay, consonants. Okay, yes, there's 26 letters in the alphabet, baby, but in this phrase, there are actually 27 letters. There you go. Yeah, these elementary teachers just kind of chiming in. Yeah, what we're gonna do with them, I don't know. Okay, y'all good? Okay. Oh, now this one. Okay, so you got to understand some things about cards, right? Do you play a lot of cards? Okay, so let me talk to you about some cards. There's a total of 52 cards, right? There's four types. We call them suits, right? In a deck, right? There's hearts, there's spades, there's clubs, and then there's diamonds, right? And every one of these have 13 cards. Because if you do 13 times 4, guess what you get? 52. And they range from anywhere from 2 up to a jack, queen, king, ace, right? Every one of these, right? So, if you randomly select a card from a well-shuffled deck of 52 cards, what is the probability that your card that you select is a diamond? Well, how many diamonds do you have? 13 out of how many cards? Which is 1/4. Ooh, look at that. We're going to send you to Vegas after all. now, do you understand why we're doing simple probability before we get into all the craziness, independent, dependent, mutual events, and all that other stuff? It's okay. That's what we're here for. All right, so that's that one. We're good. All this right here that I just wrote is, yeah, I'd make sure I understood. Like, I know that about a card, a deck of cards. Excuse me. All right, now, what else? Let's see who's on here. Who's on here? Who else is on here? Let's see. Brian and Sam. Sam, Brian, y'all doing okay? Y'all don't have any questions, or y'all just kind of put up at it? Oh, oh, I'm sorry. Okay. Okay, well, just chime in when you do. Brian, you're saying is it 75? Uh, oh yeah, yes, it was 75%. Yes, yeah. With it just being three of us, yeah. I'm when I go to my screen here, I'm not going to be able to see the chat box. So just turn your mic on and tell me, hey Palmer, do this. Is it this? Is it that? That'll be okay. I promise you. Okay, so looking at this one, what else? Number 5. Okay, so let me make sure. Okay, I'm there. I'm gonna go here. I'm gonna go here. is a good problem. I'm just going to tell you. It's a really good problem. Did y'all hear what I said? What does that mean? No. No! Um, yeah. Okay, we could do this, right? Um, according to Master Foods Company manufacturer M&Ms, 12% of M&Ms are brown. So let's just write this. Brown is 12%, and yellow is 15%, and red is 12%. Blue is 23%. Orange is 23. And green is 15%. Round your answers to the nearest three decimals. For example, 0.123, meaning take it out of a take it out of a percent and put it back as a decimal, right? So anyway, I'm just curious. Let me add these all up just so I can. So 12 plus 15 plus 12 plus 23 plus 23 plus 15. That gives me 100. Hey. Okay, good. Now that I know what I'm working with, right? So if it makes it easier, just do this. If it's out of 100%, I got 12 brown, I got 15 yellow, I got 12 red, I got 23 blue, I got 23 orange, I got 15 for a total of 100 M&Ms, right? Voila. Now, compute the probability that a randomly selected peanut M&M is not red. Well, how many of them do we have that are red? That'd be 88. 88 over 100, right? Yeah, now I think that reduces to some crazy number. I don't know. Okay, 22 over 25. Yeah, you could convert. Yeah, you could convert it to a decimal to 3 places, right? Yeah. All right. So let's look at this and compute the probability that a randomly selected peanut M&M is yellow or blue. So I'm wanting a yellow or blue, right? Yellow is 15, blue is 23. So that gives me 38 out of how many? Thank you. Now, this may be getting in too much. What's the probability that 2 randomly selected peanut M&Ms are both blue? Yeah, this is, excuse me. The first 2 are okay, but this one and this one are, at least one of them is orange. Is going to have to take into account of what we're going to be doing next week. Okay, so which problem was this? Number 5. Gone. Probability, and I don't think I put that on there. So let's see. All right. What's another one? All right. Let's see what it gives us. Oh, multiple of 4. Um, Jen. Okay. Bless you, Sam. All right. So multiples of 4, right, would be 4, 8, 12, 16, 20, right? Okay. So let's count how many of these we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have a total of 12. Now, how many of these are multiples of 4? 1, 2, and what? 3. So it'll be 3 over, huh? Nope. 2 is not a multiple. Yep, that's right. Like 0, 4, 8. Yeah, that's what multiple means. Yeah. Yeah, you'd only have 1 out of 12, right? Well, you haven't done this in quite some time, so, you know. You good? All right, what else? 8 or 9, something like greater than. How many are greater than? Now, notice that didn't say greater than equal to. It said greater than. Like if it said greater than 6, then it would be every number above 6, right? If it said less than, it's everything below that, not including that number, right? So you just got to remember that. How about the roll of a dice? You good? Do a sample space on that, and you'll be okay. Okay, they've got sample space here. So 2 dice are rolled. What is the probability the sum is 9? Well, how many of these are the sum of 9? So I don't like that. Well, okay. But let's see. A sum of 9 would have to be a what? A 6 and a 3, right? So it would be that one. It would have to be a 3 and a what? A 6. And what is it? 5 and 4 and 4 and 5, right? Yeah. Yeah. Only ones that add up to 9. Yeah. So how many of them are they? Yeah. So I've got 1, 2, 3, 4, 5, 6 this way, 1, 2, 3, 4, 5, 6 this way for a total of 36, right? So I want to show you something. They're in diagonals, right? That'd be 9. Look at this diagonal. Let me show you this diagonal. This is pretty cool. Do this one. This one right here, guess what it would be? 10. Look at this diagonal. This diagonal will be what? 11. And then that one's what? 12, right? This other diagonal over here, if I started here, would be what? 8, right? Right, 8. Yeah, right. So we've got 1, 2, 3, 4. 4 out of 36, which is 1 out of what? 9. Oh, yeah. So, but I want to show you something. This right here is really, let's do, okay, let me do this. I'm going to show you this. This is probably, all right. Let's move this. Let me do this. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. This is what I mean by sample space. If I was to do sum, right? Sum of 1 and 1 is what? 2, 3, 1 plus all of these dice. Like if I wrote a 1 on the first dice and then a 3, I'd have a 4. A 1 and a 4 would make me 5, 6, 7. And then if I wrote a 2 and a 1, I'd get a 3. 2 and 2 is 4. 5, 6, 7, 8. 3 and 1 is 4. Yeah. But right. So how many of them are 9? 1, 2, 3, 4, right? That's it. Yeah. And you can create sample spaces with with differences or all the other stuff that they may ask, you know, stuff like that. So yeah, it's pretty good stuff. All right. So what else? Let's go here. I want to go. How about this one? It's another M&M. 15. Oh, getting the sum of it. Yeah, you've got that. Getting doubles. What does it mean by doubles? 2 and a 2, 3 and a 3, 4 and 4 is 8, 6 and 6 is what? 12. So 1 and 1. So if we went back to here, you know, 1 and 1 to give me this one, right? 2 and 2 gives me 4. And then see this? Doubles. So 6 out of 36, which is 1, 6, right? A 3 and a 3 would give me a 6. So you're just using the sample space. Does that make sense? All right, said, what is the probability of getting a sum of 8? We can look at the sample space and look at that, right? Sample space of sum of getting an 8. So if we look over here, how many of these are 8? 1, 2, 3, 4, 5, right? 5 out of how many? Okay, good. Now the second question asked, what is the probability of getting doubles? Doubles means rolling 1 and a 1, 2 and a 2, 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6, right? That's what it means by double. So let's, there you go. Because see a 1 and 1 here, here, there, 4 and a 4, 5 and 5, so 6 over 36, which is 1, 6. And then last one, what's the probability of getting a sum more than 10? more than 10, right? Well, 1, 2, and what? No. How many numbers are more than 10? Look at your sample space. 1, 2, and what? Think. Not 10. More than 10. Doesn't include 10, right? There you go. Okay, so it's really helpful to do this sample space. I really like that. It's really good, just saying. Okay. Hey, here's a question. What's the probability of an event that is certain to happen? Nope. It's 1. 1 represents 100%. If it's going to happen, it's 100% going to happen, right? 1 is also 100%, right? There's some more, right? Okay, but that sample space, you ought to be able to rock and roll now, right? Uh-huh. Got it. Okay. You should be good. All right, we got tomorrow at 11. Not 11. Tomorrow at 1. And then that's just answering any last minute questions, and then your quiz is up there. But again, it's timed assessment. You got 2 hours. Shouldn't take 2 hours. Probably won't take 30 minutes. But anyway, there you go. Good. Yes. So work through what you can. And again, tomorrow's your last opportunity to be able to get any questions answered. And then you take the quiz, because then you'll be done, right? You'll be done for the week. Get it done, one thing, check. Start your weekend early, correct? No, sir. We got next week. Then the following is spring break. So we got one. I know, we got one more week, brother. One more week. So